Hello, everyone. My name is Geneva Palatini, and I am going to discuss insulin signaling pathways and diabetes mellitus for my final cell biology project. The objectives for this presentation is to elaborate on the purpose of insulin, define diabetes mellitus, identify treatment options depending on type 1 or type 2 of diabetes, explain generic signaling pathways, and then expand upon it based on insulin signaling pathways, establish a relationship between insulin and glucose and diabetes, and lastly, discuss implications of insulin on metabolism, energy, and development. Now, insulin is a very important hormone in our body that is specifically produced by the beta cells in the pancreas. It pertains to the endocrine system, as the endocrine system is just full of hormone production and regulation. This is a anabolic peptide hormone specifically, and it can act as a signal in this process. It can be comparative to a key because it helps initiate glucose to surpass the cell membrane, which is comparative to a door. Now, insulin is very impactful on the body because it can lead to various symptoms depending on the level of insulin that one has and blood glucose levels, as well as it's evident that they have an inverse relationship. You can experience hyperglycemia or hypoglycemia. Hyperglycemia is when one has high blood sugar because of low levels of insulin. This is typically as a result of pancreas not being able to produce sufficient levels of insulin, and there's just high insulin resistance as well. So, because of the low levels of insulin, high levels of glucose would occur, causing these episodes of hyperglycemia. In contrast, hypoglycemia is when one has low blood sugar. And this is when there's high levels of insulin, like, when the body is trying to overcompensate for, low levels of insulin, and they're just trying to catch up with the pace of how one's appetite and eating habits are. So then it would lead to low levels of glucose, causing the hypoglycemic episodes, which is a common reoccurring issue in diabetics in general, hypoglycemia, hyperglycemia. It's a fluctuating observation, and it's important to note that it is possible to have insulin resistance and overproduction of insulin in the body, as the body's trying to catch up and compensate, as I just mentioned. But then the body can also become almost immune to like the production of insulin because it's the pancreas is just not functioning as how it should be. And this is common, especially in overweight and obese individuals. And because of this, the continuous insulin resistance and abnormal production of insulin could result in diabetes mellitus. So, diabetes mellitus is a chronic disease. Fortunately, I hope that I don't eventually get diabetes because my dad has type 2 diabetes. It's a very difficult and sensitive disease that happens to impact almost everyone. I work at a doctor's office, and it's very common to see individuals who are diabetic and take diabetic medication. It's very aggressive, and it can inhibit one's sense of like quality of life and wellness in general. So it's very important to meet with medical professionals who are trained to treat this, like an endocrinologist, to prescribe effective medications because it can really impact an individual's physical, mental health. However, it's medically known or defined as the inability of the pancreas to produce insulin in sufficient quantities, which leads to uncontrollable blood glucose levels. Now, the symptoms are frequent urination, excess thirst, blurry vision, loss of sensation in the hands and feet, fatigue, weight loss, and more. Treatment options include insulin pumps, insulin pens, tablets, etc. Recently, there's been more medications coming out, GLP-1s, like Mounjaro, Ozempic. There's still more studies that should be conducted to expand on their effectiveness on managing diabetes because if there's an overuse of it, it can also harm the body as well. It's important to also note that it's almost like a gateway disease that could lead to other conditions like heart disease, kidney disease, cancer. So it's very important to have a good treatment team and right behind you to support you in case if you are on the risk of diabetes or trying to prevent it from happening. Now, the demographics and statistics of diabetes, really quickly, anyone can become diabetic. I noticed in elementary school there was a child who had to go to the nurse and get insulin pens every few hours, I believe, and that pertains to different classes of diabetes. However, there's a higher incidence in diabetics, particularly males and adults over the age of 45, and minorities like the indigenous, Black, Hispanic, and Asian communities. It's a very common disease. 29.7 million Americans have diagnosed diabetes as of 2024 per the CDC. There are various risk factors such as poor lifestyle habits, like little to no exercise, unbalanced diet, excessive alcohol consumption, age, race, ethnicity, family history, diabetes, prediabetes, gestational diabetes, overweight, or being obese. So here are the categories of diabetes. There's type 1, type 2, prediabetes, gestational diabetes. Type 1 diabetes is genetically inherited. That's when the immune systems attack the pancreas, and then the pancreas is incapable of insulin production. In contrast, type 2 diabetes is when one sustains a unhealthy lifestyle habits like smoking, drinking, eating really high caloric, fatty, processed foods, sugary foods. And then that's when the pancreas produces low levels of insulin because it's deteriorating and it's not supported. And there's a high resistance to insulin because the body is just trying to catch up to the lifestyle habits that an individual displays. Prediabetes is when there's high levels of blood glucose, but it's not high enough to diagnose as diabetes, whereas gestational diabetes is more pregnancy related and can become diabetes if it's not managed effectively and promptly. Now, here's a map of countries that have different percentages of diabetics. As you can see here, Asian countries, South American, indigenous, African countries. It's very unfortunate that it's so common in these areas. It's a growing concern, especially considering how insurance and the economy is going right now. So it's very important to just meet with physicians and face the reality of like, are you at the risk of getting diabetes because of X, Y, and Z? Now, the molecular aspect of it would be signaling pathways. So, signaling pathways are a series of steps, particularly just trying to communicate signals initiated by the signal itself and achieve biological processes for development and function, or more specifically known as convert extracellular information into an appropriate cellular response, as per Watson. And it's applicable to all systems and regions of the body. It's continuous and lifelong. However, it's not constant, depending on the stage that the pathway is in right now. There's different components to signaling pathways. This includes signals, receptors, signaling proteins, second messengers, effectors. There's a lot of players in this process. Examples of signals would be hormones, growth factors, cytokines. Receptors would include enzyme-linked receptors, ion channel receptors, nuclear receptors. Signaling proteins would be adapter proteins, protein kinases, lipid kinases. Second messengers would be ions, lipids, hydrocarbons. Effectors would be helper T cells, antibodies. They're the ones who were acting upon the signal that was induced by the signal itself when it binded through the receptor. Here's a very generic image of biosignaling in general. You can see here the signal molecule would bind to the receptor, it would surpass the cell membrane, and the message would be relayed, and then it would be acted upon by activation of cellular response. Here's a more dynamic image of signaling pathways and how extensive they can be. This includes apoptosis, also known as cell death, mitogenesis, glycolysis. There's tons of signaling pathways, but specifically we're going to discuss insulin signaling pathways. So insulin signaling pathways. The signal is insulin, which is a hormone. Now, the receptor would be insulin signaling receptor. They're specific to each other. The insulin signaling receptor would be known as receptor tyrosine kinase. Now, the signaling protein would be insulin protein kinase B, also known as AKT, PI3K, and the second messenger would be PIP3, which is a lipid second messenger, and the effector would be GLUT4, FOXO, and more. So essentially, insulin signaling, it's a molecular process, as you can see here. This is a very simplified version of it, but it's similar to the previous picture. Insulin would bind to the receptor, would get inside the cell membrane, and then glucose would leave the bloodstream to go inside the cell and regulate blood glucose levels. Here's a beautiful detailed picture of it and how it can start from here, and then it would go off to all these other proteins and messengers. And then here's another graphic of it as well. That's a little bit more in between of the two pictures I just showed. It would dimerize upon phosphorylation. So let's go back to the steps. So an individual would consume food. The food would deconstruct to glucose, carbohydrates, amino acids, and then specifically for insulin signaling pathways, the glucose would circulate in the bloodstream, causing the blood glucose levels to increase. So the beta cells of the pancreas would detect increase in blood glucose levels and release insulin to bring those levels down. Now, the insulin receptors that are embedded on the cell membranes would be present in skeletal muscle and adipose tissues. For insulin, it would bind to the receptor, so then it would dimerize. The receptor would dimerize, as you can see here, di as in two. So then the phosphate groups would be added to the intracellular domain of the receptor, also known as autophosphorylation, as the receptor initiated this addition of phosphate groups. So then the receptor conforms its shape based on binding, which is similar to enzymes, I feel like, because substrates would bind to the active site of the enzyme would be activated and change their shape. As we can see here, insulin signaling pathways, the receptor would be activated. So then it would add more phosphates to signaling proteins, also known as phosphorylation. Then PI3K is a signaling protein which binds to insulin's receptor signals, also known as IRS. PI3K would then convert PIP2, a signaling protein, to PIP3. PIP3 activates AKT, a signaling protein, and then it would continue to spread the signal from protein to protein as phosphorylation occurs. So it's also known as a signaling cascade. It would just continue, and then the signal would surpass the receptor to following steps in the signaling pathway, and then RAB signaling proteins would stop interacting with the vesicles. The vesicles would merge, and GLUT4 is a glucose transporter, an effector, because it transports glucose into the cell compared to outside the cell. It's like the bouncer of a club. It would bring people in, but it would be specific according to the process that is ongoing. And then blood glucose levels would decrease. Now, receptor tyrosine kinase, also known as RTKs, are insulin receptors, and phosphorylation of signaling proteins would occur, as you can see with the arrows here, go from dimerization, phosphorylation, activation to cellular response, and then two subunits of the receptor to join together, which is dimerization, and then side chains would allow additional signaling proteins to surpass and continue this cycle. Now, phosphorylation is the activation of receptors. It's very important. It creates docking sites for signaling proteins. It supports spreads of signals, dictates path for signals, what direction to go in, the activation of effectors so they can act upon it, like GLUT4, and then manage activity of insulin signaling pathways, as we can see in this diagram here. Now, glycogen, gluconeogenesis, and glucose, they all sound similar, but they're all different in very small ways. Glucose is the primary source of energy that comes from eating. Glycogen is a secondary source of energy, and it pertains to activities like sleeping, eating, not eating, anything besides eating, like sleeping, exercising, studying, anything. Glucagon is the deconstruction of glycogen to glucose. Specifically, this exhibits catabolism because as the release of energy, it's deconstructing glycogen to glucose. Gluconeogenesis is the production of glucose from lactate glycerol or glucogenic amino acids, which is relative to anabolic pathways, which requires energy to allow glucose to be produced. So then this brings us to how does insulin signaling pathways and how does it pertain to cell biology, and elaborates on many of the complex signaling pathways, and it pertains to symptoms and conditions like diabetes. It's very impactful on metabolism, insulin production, and blood glucose management, and it really emphasizes on the importance of healthy lifestyle choices, and particularly exercise and diet. So it's really encouraged to have to eat whole foods, leafy green foods, vegetables, fruits instead of fried, processed, sugary foods. So this brings us to the need for future studies to be conducted to expand on information regarding insulin signaling pathways. As I mentioned previously, how there's new medications. How does synthetic insulin impact the insulin signaling pathway? Does it, and how severe is it? Is it effective? Could it lead to long-term issues? Like I said, Ozempic and Mounjaro, there's still some more studies to be conducted to see if they have resulted in any side effects or any impacts where it actually didn't serve the reason why it was produced. What are the differences in insulin signaling pathways in humans to animals? Do mutations impact insulin signaling pathways? If so, how? It's a very fragile disease and for diabetes, and it's really important to discuss the possibilities of this because it applies to anyone. Like I said, I used to go to school with someone who had type 1 diabetes. You know, how can these synthetic medications that mimic insulin production, how do they impact metabolism and blood glucose regulation, especially for younger children? It's a very serious matter. Here are my references, and then the reason why I even discuss this is because I am interested in applying for medical school. And my dad, he struggles with diabetes on a regular basis. It's very hard to have him conform or agree to taking medications because he has his own beliefs. However, it's a very serious matter, and I'm trying my best to stay away from it and prevent the likelihood of it. Because it can really disrupt the daily functions of one's life. My father, he would have leg cramps and numbness in his toes and fingers, and he feels like he can't work, and it's very very drastic. So I'm glad that I conducted this study, this research, so that I can delve deeper and understand the molecular process of insulin signaling, how does it work and such. But yes, thank you so much, and I hope you enjoyed this presentation.